All right.
Lewis and Miller.
Yep.
Sorry. Another review pack.
We're back to normal curve.
So this is the blue sheet that was handed out in class, just to
Yes.
remind you of some things about the normal distribution, inverse normal, and z-scores.
Right.
So remember, the review section always comes from the last unit. Okay, it's been a little while.
Let's see what we can do.
Okay.
So,
Wow.
a manufacturer claims that the lifespans of their copy machines can be described in a normal model with mean 42, standard deviation of 7. What percent of the copiers are expected to fall before 36 months?
Wow. I hope you have the sheet in front of you. Can you even read that? You can read that?
I can.
You just did, I guess. All right.
Yeah.
So Mr. Lewis is going to draw a picture of the normal model.
Here's the normal curve.
So it says what percent are expected to fail before 36 months.
Okay.
So this is asking for a percent. So this is a normal CDF problem.
Right. So it wants the stuff down here.
Yeah, so the lower limit is some big negative number.
Mm-hmm.
The upper limit, it's up to 130, up to 36. So failing before 36 is 36 and below. The mean's 42. Standard deviation is 7. Mr. Lewis, this should have got a happy number of 19.6%. So that's the percent of copiers expected to fail.
Okay.
Yeah, the normal curve problems aren't so bad. I would review them a little bit.
Yeah.
In case you've totally forgotten. Number 2 says
Okay.
a manufacturer claims that lifespans for their copy machines in months can be described by a normal model. Well, the same one. Mean 42 and standard deviation 7. What is the third quartile of copier lifespans? So the third quartile is asking for a data value.
Yes.
So maybe you can draw about where 75% of the data would be. Somewhere around there. Put a little X on the bottom, or X up top, and shade the area to the left, maybe.
I only aim to serve.
Beautiful, man, beautiful.
Okay.
All right. So the question is, given the area, what's the X value, the cutoff value?
Right. So now we're gonna do inverse.
Yep. This is a straight up inverse normal because remember it handles the input is the area to the left. And then what it gives us is the cutoff value. So
0.75,
42, 7 gives us 46.7. Mr. Lewis, what does that mean if that's the third quartile?
That means that 75% of the calculators that of their lifespans are going to be below 46.7 months.
Yeah. Okay. Very good. So next one.
Thanks.
Wow.
It's a lot of words.
Let's skip that one.
Now you're starting to act like a foreman student.
Oh, come on. Don't be mean.
Okay, so let's see. The machine isn't perfect and its cost operates. There's a safety hazard on the roadway.
Blah, 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 blah,
That's
blah.
thinner than the minimum 23-inch thickness. The company of the machine averaged 26 inches for the batches of concrete.
Circle the 26. That's the mean.
Okay. They believe that the thickness level of the machine's concentrated output can be described in a normal model with a standard deviation of 1.75 inches.
Wow.
What percent of the concrete is under the minimum
You
requirement?
circle the 1.75? This is actually normal CDF because it's asking what percent's less than the minimum depth. So what percent is less than 23 inches? Because they say 23 is the minimum. So normal CDF curve.
Okay.
Very much like the first one.
Yep.
Lower limit, something big and negative. The upper limit, 23,000, right?
23,000. I think it's just 23 inches.
23. Oh, man. Delete, 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 delete. 23. And
26.
thank you.
Then 1.75. And what do we got?
4.3%.
4.3.
I'm not sure I'm comfortable with 4.3% of the road being bad.
I would have actually thought it would be higher.
But anyway, but maybe that's an acceptable tolerance. Who knows? But that's the answer to the question.
All right. Multiple choice. We like these.
Oh, yeah.
Okay, so the average snowfall is 33 inches with a standard deviation of 11. How many standard deviations from the mean is a snowfall of 66 inches? This looks like we're finding a z-score.
It is. That's what z-score answers. How far above or below the mean in standard deviations?
Okay, so we have our x value of 66.
Mm-hmm.
We subtract that from the mean of 33.
Mm-hmm.
We divide it by 11.
Mm-hmm.
And this looks like it's going to be 3.
Ooh,
Above or below?
Well, only one of them says, oh, yeah, there are two.
Yeah.
This is above.
Yes, it would be above. Because it is positive.
I would say we probably had a positive z-score for a snowfall last year in Chicago.
I would assume so. And Buffalo's definitely going
Let's
to have
go.
one.
Let's
this
go
year.
for a negative this year.
Okay.
All right.
Provide the appropriate response. Suppose the normal model describes a student score in history class. He has a standardized score.
His name
of,
is Parker. Have
I
you known anyone
guess.
by name Parker?
Spider-Man.
Wow, was that his first name?
No,
What was his first name?
Peter.
Oh, how did I not remember that? It's been a long time since I read comic books. All right, I want to do it this weekend.
Okay. This means, so if his score was plus 2.5, that means that he would be, looks like,
Cross out A has
Yes.
standard deviation 2.5. Nope.
he
Cross
is-
out C has a score that's 2.5 times the average. No.
Nope.
Cross out D, 2.5 points above average. D is probably the most tempting one.
Yes.
It is B. Remember, z-score tells us how many standard deviations above or below.
B.
All right, that's it for this review video.
Yeah, if you guys got this, we should be fine.
Okay. All right.